Antarctica is Earth's southernmost continent. It contains the geographic South Pole and is situated in the Antarctic region of the southern hemisphere, almost entirely south of the Antarctic Circle, and is surrounded by the Southern Ocean. At 14.2 million square kilometers, it is the fifth largest continent and nearly twice the size of Australia. At 0.00008 people per square kilometer, it is by far the least densely populated continent. About 98% of Antarctica is covered by ice that averages 1.9 kilometers in thickness, which extends to all but the northernmost reaches of the Antarctic Peninsula. Antarctica, on average, is the coldest, driest, and windiest continent, and has the highest average elevation of all the continents. Most of Antarctica is a polar desert, with annual precipitation of 200 millimeters along the coast and far less inland. There has been no rain there for almost 2 million years, yet 80% of the world's freshwater reserves are stored there, enough to raise global sea levels by about 60 meters if all of it were to melt. The temperature in Antarctica has reached -89.2 degrees Celsius or even -94.7 degrees Celsius, though the average for the third quarter, the coldest part of the year, is -63 degrees Celsius. Anywhere from 1,000 to 5,000 people reside throughout the year at research stations scattered across the continent. Organisms native to Antarctica include many types of algae, bacteria, fungi, plants, protista, and certain animals, such as mites, nematodes, penguins, seals and tardigrades. Vegetation, where it occurs, is tundra. Antarctica is noted as the last region on Earth in recorded history to be discovered, unseen until 1820 when the Russian expedition of Fabian Gottlieb von Bellingshausen and Mikhail Lazarev von Vostok and Mirny sighted the Thimble ice shelf. The continent, however, remained largely neglected for the rest of the 19th century because of its hostile environment, lack of easily accessible resources, and isolation. In 1895, the first confirmed landing was conducted by a team of Norwegians. Antarctica's buried active volcanoes weren't discovered until 2013. Antarctica is a de facto condominium, governed by parties to the Antarctic Treaty System that have consulting status. 12 countries signed the Antarctic Treaty in 1959, and 38 have signed it since then. The treaty prohibits military activities and mineral mining, prohibits nuclear explosions and nuclear waste disposal, supports scientific research, and protects the continent's ecology. Ongoing experiments are conducted by more than 4,000 scientists from many nations. Antarctica is divided in two by the Transantarctic Mountains close to the neck between the Ross Sea and the Weddell Sea. The portion west of the Weddell Sea and east of the Ross Sea is called West Antarctica and the remainder East Antarctica, because they roughly correspond to the western and eastern hemispheres relative to the Greenwich meridian. About 98% of Antarctica is covered by the Antarctic ice sheet, a sheet of ice averaging at least 1.6 kilometers thick. The continent has about 90% of the world's ice and thus about 70% of the world's fresh water. If all of this ice were melted, sea levels would rise about 60 meters. In most of the interior of the continent, precipitation is very low, down to 20 millimeters per year. In a few blue ice areas precipitation is lower than mass loss by sublimation, and so the local mass balance is negative. In the dry valleys, the same effect occurs over a rock base, leading to a desiccated landscape. West Antarctica is covered by the West Antarctic ice sheet. The sheet has been of recent concern because of the small possibility of its collapse. If the sheet were to break down, ocean levels would rise by several meters in a relatively geologically short period of time, perhaps a matter of centuries. Several Antarctic ice streams, which account for about 10% of the ice sheet, flow to one of the many Antarctic ice shelves. See ice sheet dynamics. East Antarctica lies on the Indian Ocean side of the Transantarctic Mountains and comprises Coates Land, Queen Maud Land, Enderby Land, Mac Robertson Land, Wilkes Land, and Victoria Land. All but a small portion of this region lies within the Eastern Hemisphere. East Antarctica is largely covered by the East Antarctic ice sheet. Vinson Massif, the highest peak in Antarctica at 4,892 meters, is located in the Ellsworth Mountains. Antarctica contains many other mountains, on both the main continent and the surrounding islands. Mount Erebus on Ross Island is the world's southernmost active volcano. Another well-known volcano is found on Deception Island, which is famous for a giant eruption in 1970. Minor eruptions are frequent, and lava flow has been observed in recent years. Other dormant volcanoes may potentially be active. In 2004, a potentially active underwater volcano was found in the Antarctic Peninsula by American and Canadian researchers. Antarctica is home to more than 70 lakes that lie at the base of the continental ice sheet. Lake Vostok, discovered beneath Russia's Vostok Station in 1996, is the largest of these subglacial lakes. It was once believed that the lake had been sealed off for 500,000 to 1 million years, but a recent survey suggests that, every so often, there are large flows of water from one lake to another. There is some evidence, in the form of ice cores drilled to about 400 m above the water line, that Lake Vostok's waters may contain microbial life. The frozen surface of the lake shares similarities with Jupiter's moon, Europa. If life is discovered in Lake Vostok, it would strengthen the argument for the possibility of life on Europa. On February 7, 2008, a NASA team embarked on a mission to Lake Untersee, searching for extremophiles in its highly alkaline waters. If found, these resilient creatures could further bolster the argument for extraterrestrial life in extremely cold, methane-rich environments. In September 2018, researchers at the National Geospatial Intelligence Agency released a high-resolution terrain map of Antarctica, named the Reference Elevation Model of Antarctica. Antarctica is the coldest of Earth's continents. It used to be ice-free until about 34 million years ago, when it became covered with ice. The lowest natural air temperature ever recorded on Earth was -89.2 degrees Celsius at the Russian Vostok Station in Antarctica on July 21, 1983. For comparison, this is 10.7 degrees Celsius colder than subliming dry ice at 1 atmosphere of partial pressure, but since carbon dioxide only makes up 0.039% of air, temperatures of less than -140 degrees Celsius would be needed to produce dry ice snow in Antarctica. A lower air temperature of -94.7 degrees Celsius was recorded in 2010 by satellite. However, it may be influenced by ground temperatures and was not recorded at a height of 7 feet above the surface as required for the official air temperature records. Antarctica is a frozen desert with little precipitation. The South Pole receives less than 10 millimeters per year, on average. Temperatures reach a minimum of between -80 degrees Celsius and -89.2 degrees Celsius in the interior in winter and reach a maximum of between 5 degrees Celsius and 15 degrees Celsius near the coast in summer. Northern Antarctica recorded a temperature of 20.75 degrees Celsius on February 9, 2020, the highest recorded temperature in the continent. Sunburn is often a health issue as the snow surface reflects almost all of the ultraviolet light falling on it. Given the latitude, long periods of constant darkness or constant sunlight create climates unfamiliar to human beings and much of the rest of the world. East Antarctica is colder than its western counterpart because of its higher elevation. Weather fronts rarely penetrate far into the continent, leaving the center cold and dry. Despite the lack of precipitation over the central portion of the continent, ice there lasts for extended periods. Heavy snowfalls are common on the coastal portion of the continent, where snowfalls of up to 1.22 meters in 48 hours have been recorded. At the edge of the continent, strong katabatic winds off the polar plateau often blow at storm force. In the interior, wind speeds are typically moderate. During clear days in summer, more solar radiation reaches the surface at the South Pole than at the equator because of the 24 hours of sunlight each day at the pole. Antarctica is colder than the Arctic for 3 reasons. First, much of the continent is more than 3,000 meters above sea level, and temperature decreases with elevation in the troposphere. Second, the Arctic Ocean covers the North Polar Zone. The ocean's relative warmth is transferred through the ice epoch and prevents temperatures in the Arctic regions from reaching the extremes typical of the land surface of Antarctica. Third, the Earth is at aphelion in July, that is, the Earth is farthest from the Sun in the Antarctic winter, and the Earth is at perihelion in January, that is, the Earth is closest to the Sun in the Antarctic summer. The orbital distance contributes to a colder Antarctic winter and a warmer Antarctic summer, but the first two effects have more impact. The aurora australis, commonly known as the Southern Lights, is a glow observed in the night sky near the South Pole created by the plasma full solar winds that pass by the Earth. Another unique spectacle is diamond dust, a ground-level cloud composed of tiny ice crystals. It generally forms under otherwise clear or nearly clear skies, so people sometimes also refer to it as clear sky precipitation. A sun dog, a frequent atmospheric optical phenomena, is a bright spot beside the true sun. The terrestrial and native all-year-round species appears to be the descendants of ancestors who lived in geothermally warmed environments during the last ice age, when these areas were the only places on the continent not covered by ice. Few terrestrial vertebrates live in Antarctica, and those that do are limited to the subantarctic islands. Invertebrate life includes microscopic mites like the Alaska Zetus antarcticus, lice, nematodes, tardigrades, rotifers, krill and springtails. The flightless midge Belgica antarctica, up to 6 mm in size, is the largest purely terrestrial animal in Antarctica. Another member of Chironomidao is Paraculus steinini. The snow petrel is one of only 3 birds that breed exclusively in Antarctica. Some species of marine animals exist and rely, directly or indirectly, on the phytoplankton. Antarctic sea life includes penguins, blue whales, orcas, colossal squids and fur seals. The emperor penguin is the only penguin that breeds during the winter in Antarctica, while the Adélie penguin breeds farther south than any other penguin. The southern rockhopper penguin has distinctive feathers around the eyes, giving the appearance of elaborate eyelashes. King penguins, chinstrap penguins, and gentian penguins also breed in the Antarctic. The Antarctic fur seal was very heavily hunted in the 18th and 19th centuries for its pelt by sealers from the United States and the United Kingdom. The Weddell seal, a true seal, is named after Sir James Weddell, commander of British sealing expeditions in the Weddell Sea. Antarctic krill, which congregate in large schools, is the keystone species of the ecosystem of the Southern Ocean, and is an important food organism for whales, seals, leopard seals, squid, icefish, penguins, albatrosses and many other birds. A census of sea life carried out during the International Polar Year, and which involved some 500 researchers, was released in 2010. The research is part of the global census of marine life and has disclosed some remarkable findings. More than 235 marine organisms live in both polar regions, having bridged the gap of 12,000 kilometers. Large animals such as some cetaceans and birds make the round trip annually. More surprising are small forms of life such as sea cucumbers and free-swimming snails found in both polar oceans. Various factors may aid in their distribution: fairly uniform temperatures of the deep ocean at the poles and the equator, which differ by no more than 5 degrees Celsius, and the major current systems or marine conveyor belt which transport eggs and larval stages. There is no economic activity in Antarctica at present, except for fishing off the coast and small-scale tourism, both based outside Antarctica. Although coal, hydrocarbons, iron ore, platinum, copper, chromium, nickel, gold and other minerals have been found, they have not been in large enough quantities to exploit. The 1991 Protocol on Environmental Protection to the Antarctic Treaty also restricts a struggle for resources. In 1998, a compromise agreement was reached to place an indefinite ban on mining, to be reviewed in 2048, further limiting economic development and exploitation. The primary economic activity is the capture and offshore trading of fish. Antarctic fisheries in 2000 reported landing 112,934 tons. Due to its location at the South Pole, Antarctica receives relatively little solar radiation except along the southern summer. This means that it is a very cold continent where water is mostly in the form of ice. Precipitation is low. Most of Antarctica is a desert and almost always in the form of snow, which accumulates and forms a giant ice sheet which covers the land. Parts of this ice sheet form moving glaciers known as ice streams, which flow towards the edges of the continent. Next to the continental shore are many ice shelves. These are floating extensions of outflowing glaciers from the continental ice mass. Offshore, temperatures are also low enough that ice is formed from seawater through most of the year. It is important to understand the various types of Antarctic ice to understand possible effects on sea levels and the implications of global cooling. Sea ice expands annually in the Antarctic winter, and most of this ice melts in the summer. This ice is formed from the ocean water and floats in the same water and thus does not contribute to rise in sea level. The extent of sea ice around Antarctica in terms of square kilometers of coverage has remained roughly constant in recent decades, although the amount of variation it has experienced in its thickness is unclear. Melting of floating ice shelves, ice that originated on the land, does not in itself contribute much to sea level rise, since the ice displaces only its own mass of water. However, it is the outflow of the ice from the land to form the ice shelf which causes a rise in global sea level. This effect is offset by snow falling back onto the continent. Recent decades have witnessed several dramatic collapses of large ice shelves around the coast of Antarctica, especially along the Antarctic Peninsula. Concerns have been raised that disruption of ice shelves may result in increased glacial outflow from the continental ice mass. On the continent itself, the large volume of ice present stores around 70% of the world's fresh water. This ice sheet is constantly gaining ice from snowfall and losing ice through outflow to the sea. Some of Antarctica has been warming up. Particularly strong warming has been noted on the Antarctic Peninsula. A study by Eric Steig published in 2009 noted for the first time that the continent-wide average surface temperature trend of Antarctica is slightly positive at more than 0.05 degrees Celsius per decade from 1957 to 2006. This study also noted that West Antarctica has warmed by more than 0.1 degrees Celsius per decade in the last 50 years, and this warming is strongest in winter and spring. This is partly offset by autumn cooling in East Antarctica. There is evidence from one study that Antarctica is warming as a result of human carbon dioxide emissions, but this remains ambiguous. The amount of surface warming in West Antarctica, while large, has not led to appreciable melting at the surface, and is not directly affecting the West Antarctic ice sheet's contribution to sea level. Instead, the recent increases in glacier outflow are believed to be due to an inflow of warm water from the deep ocean, just off the continental shelf. The net contribution to sea level from the Antarctic Peninsula is more likely to be a direct result of the much greater atmospheric warming there. In 2002, the Antarctic Peninsula's Larsen B ice shelf collapsed. Between 28 February and March 8, 2008, about 570 kilometers square of ice from the Wilkins ice shelf on the southwest part of the peninsula collapsed, putting the remaining 15,000 kilometers square of the ice shelf at risk. The ice was being held back by a thread of ice about 6 kilometers wide, prior to its collapse on April 5, 2009. According to NASA, the most widespread Antarctic surface melting of the past 30 years occurred in 2005, when an area of ice comparable in size to California briefly melted and refroze. This may have resulted from temperatures rising to as high as 5 degrees Celsius. A study published in Nature Geoscience in 2013 identified central West Antarctica as one of the fastest warming regions on Earth. The researchers present a complete temperature record from Antarctica's Bird Station and assert that it reveals a linear increase in annual temperature between 1958 and 2010 by 2.4 degrees Celsius. In February 2020, the region recorded the highest temperature of 18.3 degrees Celsius, which was a degree higher than the previous record of 17.5 degrees in March 2015. There is a large area of low ozone concentration or ozone hole over Antarctica. This hole covers almost the whole continent and was at its largest in September 2008, when the longest-lasting hole on record remained until the end of December. The hole was detected by scientists in 1985 and has tended to increase over the years of observation. The ozone hole is attributed to the emission of chlorofluorocarbons into the atmosphere, which decompose the ozone into other gases. In 2019, the ozone hole was at its smallest in the previous 30 years, due to the warmer polar stratosphere weakening the polar vortex. This reduced the formation of the polar stratospheric clouds that enable the chemistry that leads to rapid ozone loss. Some scientific studies suggest that ozone depletion may have a dominant role in governing climatic change in Antarctica and a wider area of the southern hemisphere. Ozone absorbs large amounts of ultraviolet radiation in the stratosphere. Ozone depletion over Antarctica can cause a cooling of around 6 degrees Celsius in the local stratosphere. This cooling has the effect of intensifying the westerly winds which flow around the continent, the polar vortex, and thus prevents outflow of the cold air near the South Pole. As a result, the continental mass of the East Antarctic ice sheet is held at lower temperatures, and the peripheral areas of Antarctica, especially the Antarctic Peninsula, are subject to higher temperatures, which promote accelerated melting. Models also suggest that the ozone depletion-enhanced polar vortex effect also accounts for the recent increase in sea ice just offshore of the continent. Due to its location at the South Pole, Antarctica receives relatively little solar radiation except along the southern summer. This means that it is a very cold continent where water is mostly in the form of ice. Precipitation is low. Most of Antarctica is a desert and almost always in the form of snow, which accumulates and forms a giant ice sheet which covers the land. Parts of this ice sheet form moving glaciers known as ice streams, which flow towards the edges of the continent. Next to the continental shore are many ice shelves. These are floating extensions of outflowing glaciers from the continental ice mass. Offshore, temperatures are also low enough that ice is formed from seawater through most of the year. It is important to understand the various types of Antarctic ice to understand possible effects on sea levels and the implications of global cooling. Sea ice expands annually in the Antarctic winter, and most of this ice melts in the summer. This ice is formed from the ocean water and floats in the same water and thus does not contribute to rise in sea level. The extent of sea ice around Antarctica in terms of square kilometers of coverage has remained roughly constant in recent decades, although the amount of variation it has experienced in its thickness is unclear. Melting of floating ice shelves, ice that originated on the land, does not in itself contribute much to sea level rise since the ice displaces only its own mass of water. However, it is the outflow of the ice from the land to form the ice shelf which causes a rise in global sea level. This effect is offset by snow falling back onto the continent. Recent decades have witnessed several dramatic collapses of large ice shelves around the coast of Antarctica, especially along the Antarctic Peninsula. Concerns have been raised that disruption of ice shelves may result in increased glacial outflow from the continental ice mass. On the continent itself, the large volume of ice present stores around 70% of the world's fresh water. This ice sheet is constantly gaining ice from snowfall and losing ice through outflow to the sea. Shepard et al. 2012 found that different satellite methods for measuring ice mass and change were in good agreement, and combining methods leads to more certainty with East Antarctica, West Antarctica, and the Antarctic Peninsula changing in mass per year. The same group's 2018 systematic review study estimated that ice loss across the entire continent was 43 gigatons per year on average during the period from 1992 to 2002, but has accelerated to an average of 220 gigatons per year during the 5 years from 2012 to 2017. NASA's climate change website indicates a compatible overall trend of greater than 100 gigatons of ice loss per year since 2002. A single 2015 study by H.J. Zwally found instead that the net change in ice mass is slightly positive at approximately 82 gigatons per year, with significant regional variation which would result in Antarctic activity reducing global sea level rise by 0.23 mm per year. However, one critic, Eric Rignott of NASA's Jet Propulsion Laboratory, states that this outlying study's findings are at odds with all other independent methods, reanalysis, gravity measurements, mass budget method, and other groups using the same data, and appears to arrive at more precise values than current technology and mathematical approaches would permit. A satellite record revealed that the overall increase in Antarctic sea ice extents reversed in 2014, with rapid rates of decrease in 2014 to 2017, reducing the Antarctic sea ice extents to their lowest values in the 40-year record. East Antarctica is a cold region with a ground base above sea level and occupies most of the continent. This area is dominated by small accumulations of snowfall which becomes ice and thus eventually seaward glacial flows. The mass balance of the East Antarctic ice sheet as a whole is thought to be slightly positive or near to balance. However, increased ice outflow has been suggested in some regions. Meteorites from Antarctica are an important area of study of material formed early in the solar system. Most are thought to come from asteroids, but some may have originated on larger planets. The first meteorite was found in 1912, and named the GREENLAnd meteorite. In 1969, a Japanese expedition discovered 9 meteorites. Most of these meteorites have fallen onto the ice sheet in the last million years. Motion of the ice sheet tends to concentrate the meteorites at blocking locations such as mountain ranges, with wind erosion bringing them to the surface after centuries beneath accumulated snowfall. Compared with meteorites collected in more temperate regions on Earth, the Antarctic meteorites are well preserved. This large collection of meteorites allows a better understanding of the abundance of meteorite types in the solar system and how meteorites relate to asteroids and comets. New types of meteorites and rare meteorites have been found. Among these are pieces blasted off the Moon, and probably Mars, by impacts. These specimens, particularly, are at the center of the controversy about possible evidence of microbial life on Mars. Because meteorites in space absorb and record cosmic radiation, the time elapsed since the meteorite hit the Earth can be determined from laboratory studies. The elapsed time since fall, or terrestrial residence age, of a meteorite represents more information that might be useful in environmental studies of Antarctic ice sheets. In 2006, a team of researchers from Ohio State University used gravity measurements by NASA's GRACE satellites to discover the 500-kilometer-wide Wilkes Land crater, which probably formed about 250 million years ago. In January 2013, an 18-kilogram meteorite was discovered frozen in ice on the Nansen ice field by a Search for Antarctic Meteorites, Belgian approach mission. In January 2015, reports emerged of a 2-kilometer circular structure, supposedly a meteorite crater, on the surface snow of King Baudouin ice shelf. Satellite images from 25 years ago seemingly show it. If you learned something new today, then give us a like, and subscribe our channel for more updates.